The second part of our lesson is going to expand on the distributive property. We're going to use a distributive property twice, so it's really a double distributive property that we're going to be using when we multiply two binomials together. So the emphasis is going to change. If I flip back to a previous page, we always had a monomial times either binomial or monomial times a trinomial. But if you look at the new example, just kind of previewing those, we have binomials times binomials. So there's a binomial times another binomial, and the same thing for the other examples I have written down here to go through. So what we're going to do is we're going to use the distributive property twice. If we would try to apply our PEMDAS method on this from the very get-go, we're in trouble because there's nothing that we can simplify in either of these sets of parentheses. They're not like terms, so we'd be stuck if we didn't have another method. So that's where this double distributive property comes in. It's called the FOIL. So some things that we can try to look at here just for the moment. I'm going to pause and then come right back. Okay, what I want to do is I want to grab this block. We're going to multiply. And again, here's this implicit multiplication sitting here again. If you don't see something in between two parentheses, it always implies, it implicitly says to multiply. So we're going to use our distributive property to help us multiply the first binomial times the second binomial. So we're going to use the distributive property twice. And if I covered up that p, and if you saw that, that would be like the previous examples. You would have to take this 8 times the p and then the 8 times the 8. I would distribute it once. But because there's two things inside of this parentheses, I can't get by with just distributing once. I would also have to distribute the p. So we're going to distribute the value of p as well. So p is going to get multiplied times p, and p is going to be multiplied times 8. So that's what the double distributive property in my mind means, that I have to distribute not just once but twice, because there are two things in this set of parentheses. There is a binomial represented here, which means both of them have to be distributed and multiplied. So the acronym FOIL, where does that come in? Whenever we multiply two binomials times another, or two binomials together, what we can do is we can apply this FOIL concept, which is an acronym which says multiply the first terms in each binomial together. So that means I'm going to take p times p. So I can see a little bit better. It's p plus 8 times p plus 8. So the first numbers, or the first terms in each binomial is p. So I'm going to take p times p. And then I'm going to do the outermost two. To me, the outer terms, the ones that are farthest apart, are p times 8. And then I want to go with the I. The I says multiply your innermost one. So now I'm working on that double distributive. I multiplied through by the p. Now I'm going to do it a second time with the 8. The I stands for the inner ones. And the L in FOIL says don't forget to multiply the last two terms in your binomials together. So there's a multiplication that we have to do. So on our first one, we're going to do p times p. It's going to be p squared. We're going to take p times 8, which is 8 times p. Then I'm going to take the 8 and multiply it times the p, and again that's going to give us an 8 times p. Then I take the last terms and multiply them together, and that's 8 times 8, or 64. Okay, now what we're going to do is we're going to look for collecting like terms, and if you remember what like terms were, they are the things that have exactly the same variable, 8p and 8p. We have like things. The p squared is different, but the 8p and the 8p can be collected into 16p's plus 64. And this is our final expression that we have simplified in effect through the use of the distributive property. So there's our first run through with FOIL. Let's go through it again. Again, what we're doing on this problem is we're multiplying two binomials together. So I'm going to take 2c plus 1. I'm going to multiply it times c minus 5. The multiplication of the times is implied anytime we have two parentheses next to each other. So now I'm going to do the first term. The first terms tell me to do 2c times c, which is 2c squared. Then I'm going to do the outermost, the O in FOIL. So now I've got 2c times a negative 5. That is a 2c times a negative 5, which is a negative 10c. Then I'm going to have to make sure I go back through and distribute with my second term in the binomial. So this is the double distributive part. Now I'm going to work on the innermost ones. So that's 1 times c, which is just c. And then the innermost ones go to the last in the FOIL. So we have the I for the innermost. This is my last. And it's a positive 1 times a negative 5, and a positive 1 times a negative 5 is a negative 5. We're going to look for any like terms that we may have, and there are two like terms sitting right in here. They're typically the middles. You got 2c squared. You have a negative 10c plus a c, so you have negative 10 plus one of them is a negative 9c minus 5. And there's our answer to our second one. So the rest of these are just more examples of the same idea, applying this concept to different looking ones. We got a 3m plus 4. Here's a binomial. We want to take it times another binomial, 2m minus 5. We've got this implied multiplication. We have binomial times binomial, so we want to apply our distributive property so that we can simplify some like terms. As it is, there's no simplifying that we can do in either of our parentheses. So I'm just again pointing out that order of operations doesn't help us at this point. So we're going to come through with our first terms. We're always going to multiply our first ones in each binomial together. That's our first. That's a 3m times a 2m. And 3 times 2 is 6. So I got 6. And m times m is m squared. Then I got to do the outermost 2. So the outermost 2 forces me to multiply the 3m times a negative 5. So a 3 times a negative 5 is a negative 15. And then times the m. Now we're going to do the innermost 2, the two that are closest together. That's a 4 times a 2m, which is 8m. And then we're going to finish off our distributive property with our last, our L, and that's a 4 times negative 5, which is a negative 20. Once you get done distributing, then we're going to collect our like terms. So 6m squared. As I said, most of the time they're in the middle. They don't have to be, but most of the time they are. It's a negative 15m plus 8m. That's a negative 7m minus 20. We collected all our like terms, and we simplified number 13 as much as we could. And to finish this off, we'll do one more. We got 2q minus 17, and we got q plus 2. What you want to be really careful with is how you handle these subtraction signs or negative signs in essence. If you don't like that, the negative sign or the subtraction sign, you can write as 2q, and you can always remember that subtraction is always adding the opposite, so you could change it to plus a negative 17. To me, that's kind of just an extra step that you don't necessarily have to do if you can remember that you got a negative sitting there. But that's another option that you can do. So if you'd like to, you can write it that way. I'm going to stay away from that for a little bit, and I'm just going to go ahead and distribute our first outside, inside, last. So our first terms is a 2q times q, which is 2q squared. And our outermost, we've got a 2q times 2, which is 4q. On our innermost, it's a negative 17 times q, so it'll be a negative 17q. And in our last, it's a negative 17 times 2, and negative times positive is negative, that'll be a 34. Collect your like terms. Our like terms are situated in the middle again. You got 2q squared. Then you got more negatives than positives, 17 negative and 4 positive. You're going to end up with negative 13q minus 34. Okay, this is the double distributive property. We're going to utilize the FOIL technique whenever it's a binomial times a binomial. Don't confuse that with our monomials that we were working with earlier. I'm just going to highlight when there's a monomial in front, that's single distribution. But when you have a binomial, as we had on these, I guess I went too far. Binomial means you have to distribute twice, and we can carry on this process with a trinomial times a binomial and so on. That's as far as we're going to work today. So that gets us through our second lesson.